Student friends, in yesterday's lecture we started with the second topic, namely transistor biasing. Yesterday we introduced the topic and then we have studied why biasing is necessary under the title known as need of biasing. For your revision purpose, biasing is a process in which one can connect proper magnitude and proper polarity power supply, the B.Sc-II, to the transistor so that it will set the proper base current, emitter current and collector current at the cost of emitter to base voltage VBE and collector to emitter voltage VCE to stabilize the operation of transistor in a proper region depends upon the purpose for which that transistor is being used, and that is whether it is going to be operated in the active region or it is going to be operated in saturation and cutoff region to work it as an amplifier or to work it as a switch. For that particular purpose, we need the biasing, and we are aware that biasing is going to depend upon the location of the operating point in a respective region, and that is going to depends upon the aspect of stabilization. Means by providing the necessary bias, operation of BJT is stabilized, and its stabilization is going to depend upon the operating point. Student friends, today we are going to consider the same concept of the operating point. So what do you mean by operating point? Operating point is the point in the output characteristics of transistor on the load line around which the entire operation of transistor depends. Means the working of transistor is going to depend on the location of the point, and that point we can call it as it is the operating point. We can also define operating point in the another way, and that is it is point on the load line around which operation of transistor is silent. Because of this particular aspect, sometimes operating point is called as the quiescent point. One can define operating point also as it is a point on the load line around which the variation of IC and VCE are taking place. So all these definitions are valid for the point which is located on the load line in the respective region of output characteristics of B.Sc-II. By knowing the operating point, we have to locate that particular point on the load line, and to locate that particular point on the load line so as to stabilize the working of B.Sc-II, it is necessary to study the meaning of the load line also. Let us begin with the understanding of the operating point. Operating point is the point on the load line in the active region around which the entire operation of B.Sc-II depends and takes place. Means it is a point on the load line around which the operation of B.Sc-II is done, or around that particular point the working of B.Sc-II depends. That point is called as the operating point. It is a point on the load line around which IC and VCE varies. Around that particular point only the output current IC and the voltage VCE varies. Operating point is denoted by Q. Symbolically it is represented by Q. That decides the operation of B.Sc-II for particular application. Means operating point decides the operation of B.Sc-II for a particular operation. Means whether it is to be going to be act as a switch or it is going to be act as an amplifier. It is decided by the location of the operating point. It is also called as a quiescent point because B.Sc-II is silent around the operating point. Friends, let us locate the same operating point Q on the load line, and that's why we are going to study the meaning of DC load line. Basically DC load line is a straight line, and by virtue of geometry we are aware that to plot the straight line we need 2 points, and once we have 2 points, if we join it we can get a straight line, and this is the concept that is used to draw the line. But we are drawing this line on the output characteristics of B.Sc-II, and to draw that particular line on the output characteristics of B.Sc-II we are interested to those 2 particular points which by joining we can get a straight line on that output characteristic curve. And if we get a straight 2 points and a straight line by joining them on the output characteristic curve, so line obtained is called as the DC load line. Once we have obtained that particular load line, by trial and error method we are going to locate the operating point on that particular line, which is going to decide the entire operation of B.Sc-II, whether it is to be operated as an amplifier or it is going to be operated as a switch. Now our job is to find those 2 particular points to be located and join those 2 particular points so as to draw a line on the output characteristic curve to be referred as the DC load line, because we are applying only DC supply to plot that particular load line. Let us see how the load line is going to be drawn on the output characteristic curve. So DC load line, it is the line on the output characteristic curves of BZD in common emitter configuration. Means we are considering now, out of three configurations of BZD, as we are aware that BZD has got a three terminal, namely emitter, base and collector. Depends upon that. Last year we have studied BZD can be used in three different configurations. One, it is used in common emitter configuration. Second one, it is used in common base configuration. And third one, it is used in common collector configuration. Out of three, here we are considering the BZD in common emitter configuration to draw the DC load line. By considering the BZD in common emitter configuration or its output characteristic curve, and then we are going to determine the 2 points to join it. It is the line on the output curves of IC and VCE axis. We are aware that in common emitter configuration, to plot the output characteristic curve, which we have already plotted in the last year, these are the graph of output current IC versus output voltage VCE, and by using the same graphs, we can say that the load line is the line on the output curves of IC and VCE axis. It is called as a DC load line as BZD is operated by DC voltage VCC. After plotting the load line, position of operating point Q is fixed by trial and error method on the load line. To plot the load line, we have an equation which we have studied last year, and that is VCC equal to VCE plus ICRC. VCC is the DC supply voltage for the operation of BZD so as to bias the respective junctions in a respective manner as per the operation of BZD. VCE is the voltage developed across collector and emitter. IC is its collector current. RC is the load resistance, or it is called as collector resistance. Let me call this as equation number 1. To proceed further, if we put VCE is equal to 0 in equation 1, meaning thereby if you put VCE equal to 0 in equation number 1, when VC is replaced by 0, we can get VCC equal to ICRC. Let us proceed. By putting VC equal to 0 in equation number 1, we can get VCC is equal to ICRC. That is IC equal to VCC upon RC. Thus we get a first point which is located on the IC axis of the output characteristic curves, and the point is, let us suppose that point as the A, and that's equal to 0 VCC upon RC. These are the coordinates of point A. Obviously, this point is located on IC axis because it is the point on Y axis. On Y axis, X coordinate is 0 by geometry. So as X coordinate is 0, this point is definitely going to be located on the Y axis, and that is IC axis. Now put IC equal to 0 in equation number 1 so that equation becomes VCC equal to VCE. This equation is obtained by putting IC equal to 0. If IC equal to 0, ICRC is 0. When ICRC is 0, then VCC equal to VCE. So that is what we have obtained here. We get another point on BCE axis now. That point is say B, whose coordinates are BCE is 0. Here y coordinate is 0, and we know that when y coordinate is 0, then that point is located on the x axis, and here x axis is the BCE axis. So point A is available on IC axis, point B is available on BCE axis. Now our job is we have to join these two particular points, that is point A, that is BCC upon RC, that is point A, that is 0 BCC upon RC, and point B, it is BCE 0. We get a straight line on the output curves of IC against BCE, because by virtue of geometry, when we join 2 points, we will get definitely a straight line, and this straight line is on the output of the load line or on the output characteristic curve, which we are going to represent here. Look at here, these are the output characteristic curve, which are the graph of IC versus BCE. So IC versus BCE is the graph of output characteristic curve, which we already plotted last year. So these are the graphs for constant value of IB. For fixed value of IB, you can plot the different output characteristic curve. So as these curves are available with us, we have already determined the 2 points. One is the point which is going to be located on the IC axis. That point is called as BC is 0, IC equal to BCC upon RC. Another point is here, for which value of IC is 0 and BCE equal to BCC. So let us determine. So we can got it BCE equal to BCC. So this is the another point we can got it. One point is on BC axis, another point is on IC axis. Join these two particular points. If you join these 2 points, we can get a straight line, which is represented by a red line. This line we can call it as it is the load line, which is located on the output characteristic curves. Is it clear? So with this process, one can plot the load line on the output characteristic curves. We are aware that the entire operation of BZT is divided into 3 regions, which I already studied last year. One in the saturation region, where transistor is totally on, where both the junctions are forward biased, maximum collector current flows, that is BCC upon RC. Another one is the cutoff region, where transistor is totally off, collector current is 0. If operating point is located in the cutoff region, transistor is off. If operating point is located in the saturation region, transistor is fully on. If transistor operates either in the saturation region or in the cutoff region, then transistor is going to be act as a switch. If suppose operating point is located between point B and A, within this particular point, anywhere, this region we can call it as it is the active region. Most probably operating point when located on the center of the load line, this is represented here, which we can call it as a Q point. Then input junction of B.Sc-II is forward biased and output junction of B.Sc-II is reverse biased. During this particular Q point, IC will be located here, VCE will be located here. So around this particular point, the variation of IC and VCE that takes place. This point we can call it as it is the operating point. This is the point around which the operation of B.Sc-II depends. This is the point around which the transistor is silent. So thus, by trial and error method, you can locate operating point either on the center of the load line to work B.Sc-II as an amplifier, or it may be shifted from active to saturation or from active to cutoff to work B.Sc-II as a switch. So this is how one can locate the operating point B.Sc-II on the load line and allow B.Sc-II to work as an amplifier, or it is going to work as a switch. Friends, this is how, but using trial and error method, one can locate the operating point. So same we are going to describe, as operating point is the point on the load line in the active region around which the entire operation of B.Sc-II depends or it takes place. It is a point on the load line around which the IC and VCE varies. Operating point is denoted by Q that decides the operation of B.Sc-II for particular region. It is also called as a quenchant point, as B.Sc-II is silent around this particular point. Generally, operating point is located on the center of the load line, in which the input junction is forward biased and output junction is reverse biased to act it as an amplifier. If operating point is at cutoff, B.Sc-II doesn't conduct IC, and if it is in saturation, it fully conducts IC. Then B.Sc-II is going to act as a switch. Friends, biasing means what now? By setting the proper collector current IC, by supplying the proper power supply VCC, once the operating point is placed in the respective region, then it should be remain at the same point till and until the completion of operation of that particular B.Sc-II. If there is a shift of operating point takes place due to one or more factors, due to one or more reasons, then the operation of B.Sc-II is going to be hampered. And this hampering of working of B.Sc-II will disturb the stability of operating point. Hence, the working of B.Sc-II is also unstabilized. Under this particular situation, we have to stabilize that particular operating point so as to stabilize the operation of B.Sc-II. And hereafter, our job is, if the operating point of B.Sc-II is disturbed due to some factors, then it is made to be stabilized. And to make the stabilization of the working of B.Sc-II, we are going to apply the different methods of biasing, and which we are going to study in the forthcoming lectures. Friends, that's all about operating point, meaning of DC load line, how it is plotted, and how operating point is located by trial and error method on the output characteristics of B.Sc-II. So that's all about today's lecture. Next time we will meet with next article of the same topic.